All right. So good morning, everyone. So today we go to jump to another concept, which is VPN. So we do it quickly so that we can demonstrate the uh, configuration wise in Fortigate. So we go to touch base on some of the concept behind the VPN and then how it relates to network security. So this will be our lab for to demonstrate the concept. I've already configured this one, and yesterday I configured this one too. I just to save time, and I've configured this device too. So we're going to simulate the device as our internet. So this one will be our branch office. This will be our headquarters. So between the two, we're going to create a tunnel from point A to point B. So, but before we do that, let's touch base on some of the concepts behind VPN. Before now, this is one of the central questions in interview, but things are getting changed now, but it is still good to have the knowledge in our toolbox. So it's good to know it. It's good to know some of the configuration pattern and then how it can be troubleshooted. So let's get started. So I have this agenda for today. We're going to talk about VPN. We're going to talk about the understanding the architecture. And then we're going to touch base on IKphase1 and phase 2. And then we're going to configure IPsec between FortiGate to FortiGate. And after that, we test the connectivity. So let's start from the VPN. Okay, the VPN is a virtual private network. It's like other network we have touched base on. We talk about LAN, and then we talk about WAN. So VPN is an overlay. It's an overlay network. It's a virtual network. It is not a physical network like WAN or like LAN or WAN. So it is overlay between the two. What it means is it is a subset of these two, because if we don't have an already LAN, we can't connect or we can't establish VPN on them. So there should be a configured LAN before we can set up a VPN on them. So VPN is a technology designed to provide a secure tunnel or secure connectivity over the internet. It is a technology designed to provide secure connectivity over the internet to provide extra layer of security to traffic. It could be private traffic, could be transactional private traffic. So VPN itself, it is a framework design that has a lot of parameters that form a circle. That is internet internet security protocol, and then it form some communication encryption protocol. And up to now, we have seen different versions, but currently we are using IKE version 2. IKE version 2 is the one current now, because IKE version 1 has been known to have some vulnerabilities. So people behind this development majorly, especially on the IK version 2, is Cisco and Microsoft. They designed this particular one, but IK version 1 has been on for a long time. But the take home in VPN is we just need to know that VPN itself, it is a framework of different parameters to encrypt and decrypt information, or encrypt and decrypt packets over the internet. Can VPN be used in a private network, in a LAN? The answer is yes too, if we have a need for it, because VPN is designed based on need. For example, now, we may decide to use layer 2 VPN, which is GRP. Is it GERP? This is grep. Yeah, it's grep. This is layer 2, but most of the time, this one can be used in an internal environment. But before the introduction of IPsec, it was used over internet. But when the IPsec was introduced and all the devices, they were able to process it. Because one thing about VPN is this. One thing is to configure it. Another thing is the device is capable of those encryption protocols. So before we move on to some of the parameters or some of the types of VPN, the purpose of VPN is to provide CIA of information. The benefit to benefit from VPN is to ensure that there's a CIA of data. It gives CIA of data. That is, it gives the confidentiality. That is, the packet has not been tampered with in between the client and the server. Because when we are setting up the VPN, it is between a client and server. There will be an initiator, there will be a responder. So that is why it is always good to look at all this configuration from that perspective. It is not a standalone information. That is, it can be set up only one side. No, it will be between two sides. Whether IPsec or SSL is always between two locations. It provides confidentiality, it provides integrity. Because integrity-wise, the packet, it can be verified. It can be verified and ensure that it's still the same packet we sent. Or it can still be authenticated to confirm that we are who we claim to be. So all these benefits of CIA, confidentiality, integrity, authentication, they are formed by different layers of parameters. And then if you go down a little bit, we'll start talking about parameters of IPsec. We will see that each of those parameters are not developed by one individual. They are combination of efforts. They are a combination of effort, and then they are industry standard. What does that mean is it's an open source, and then each and every device participating in the VPN should conform to those standards. It is not what I can wake up tomorrow and bring my own method. That is, I want to be using this, or I want to be using that. No, there's an already laid standard, and then we can adapt it. It's like every other standard, like OSI, where OSI and some other standard like NIST documentation that have been laid down for all the vendors, either standalone vendors or multi-vendors companies to follow. So VPN itself is just a framework that defines how packet can be protected or encrypted over the internet. But we have different types of VPN. So there are so many of them that we don't need to discuss here right now, but we're going to touch base on this major two, which is IPsec VPN and SSL. There are more of them. Even in Fortigate, they'll have ADVPN. We have ADVPN. So, but we're going to touch base on these two. Other one I mentioned, they are part of this majorly, but they have some different configurations, but they give them different names. So we will touch base on some of them as we move forward. Now, the one I will start with is IPsec. That is Internet Protocol Security. IPsec, it is a suite of frameworks designed to set up between point A and point B. It's majorly used between two sites. That is, it could be from headquarters and branch. It could be from branch to headquarters. It could be from one location to another location. Sometimes when we have a business and then we have some partners, and they want to ensure that our connectivity between the 2 points are encrypted. This is our partner. Maybe we have a partner in London and then our business is situated in New York, for example. We want to ensure that any traffic we share, because of confidentiality aspect of VPN, we want to ensure that our information is adequately secure. Because the reason behind all this is this: we cannot presume that there are no vulnerability or there's no bad actor out there shoving the internet, looking for vulnerability or looking for session they can hijack. Some people, they have designed so many methods to filter internet. As we are here, some people's job is to filter internet to capture as much as data they can, and they will later analyze it. And that is what one of the features of IPsec, it has anti-replay capability. So people capture data now, they want to replay later, they want to analyze it. So IPsec has some capability that can prevent that. Even if you capture my packet, if you replay it, it will not be meaningful. So an IPsec itself, it is not just only the name that make it. There are some setup, there are some parameters in between that complete the suit. But IPsec is a type of VPN in terms of configuration wise. IPsec says it's not a standalone, say it's a VPN. No, it is class of VPN that we can be configured. So most of the time, IPsec VPN can be configured between two devices. Even we can configure IPsec VPN from a router and a firewall. We can configure a IPsec VPN from a firewall and a PC. This Fortigate gives that room. They have different capability of setting up IPsec in their solutions. For example, now, if I decide to have I have a firewall here now. This is my Fortigate. And I have my PC here. I may decide to set up site-to-site VPN between two of them. Why? Fortigate has a client. In their client, there's a functionality in their client that gives room or that enable their endpoints to set up either SSL VPN or IPsec. So we can set up IPsec VPN between the firewall and a laptop or a PC or a workstation, as case may be. But it's a very rare occasion, but they have the function, they have the feature in their VPN client. So having said that, what about the SSL VPN? SSL VPN is a secure layer VPN, socket secure layer VPN. This one is majorly designed to enable teleworkers, people that move around, to connect their PC to the branch, to connect their PC to the headquarters. For example, now many of us who are working from home, we use this particular form of SSL form of VPN. What does that mean? We have this SSL VPN clients in our PC installed by the organization. Sometimes they set it up, sometimes they have to set it up ourselves. But they must have set up our device to be part of the VPN configuration before giving it to us. It's not what can be set on the fly, because each of these connectivity has a gateway. So our device or our user ID, or it depends the functionality or the parameter they set up, must have joined that group. Our own is to connect from our house a gateway. There will be a gateway we can link to, and then we'll connect to it, and then it will route us back to the organization network. And it will now seem as if we are in the location. So SSL VPN is majorly designed for remote workers or teleworkers, or to enable some of the organizational workers that move around to connect back to organizations in securely that seems as if they are still in local. There are so many flavors of configurations of VPN, but every vendors have their own uniqueness, but the standard remains the same. It's like going to the market, buy a cassava or buy a plantain. You can make it to be whatever you want it to be, but it's still cassava. So the same thing applies to this standard. Every vendors, they have their own different ways they can set it up, but the bottom line is they all provide certain functionalities. VPN is VPN, and the IPsec is IPsec in every vendor, but they have different configuration. Like when we start going to the lab, we see how Fortigate or Fortinet design their own IPsec, and they will follow the pattern, and they will see how it behaves. So that is all about IPsec. In IPsec, we have now I want to be talking about the setup or some of the functionalities that can make up the secure tunnel. First of all, we need to look at the method they use to form the tunnel. We'll be talking about IK version 1 and IK version 2. These two concepts, or these two technologies, they became available in different time. Like I said before, IK version 1, most of the vendors, they decide not to go this route again because it has been known to have some vulnerability. So the best version now, as we speak, is IK version 2, but they still have similar pattern. IK version 1 and IK version 2, they both have phase 1 and phase 2. They both have phase 1, and phase 2. Now, I'm talking primarily on IPsec, not on SSL. SSL doesn't have this kind of phase. But in IPsec, we have phase 1 and we have phase 2. If you look at it closely, the phase 1 and phase 2, they have similar configuration. They have similar parameters, but I will dissect them one by one. So in phase 1 of IPsec, the security association will be sent to create the tunnel. So if we are asked what is the purpose of the phase 1 parameters is meant to create the tunnel that the phase 2 will be used. So in IK phase 1, in IK version 1, 6 messages will be sent across the board from the initiator to the responder. So let me say this is the point 1. We have our firewall here, firewall A, and the firewall B. One of these will become initiator, one will be responder. So from the initiator to responder, there will be packets or messages sent across. And then the response will be coming from the responder as well. So these packets, they are 6 in number. And this packet will contain some authentication pattern to contain the IP headers. So the technology designed to provide layers on top of the our IP headers inside the tunnel. It's not manipulating it. It's just providing extra layer of security on top of our original IP so that it will not be seen across internet. Even if it's captured, this guy or any other bad actor will not be able to see it. So all the parameters we'll be mentioning shortly, they are part of that format or that part of that parameter that set up the tunnel. So phase 1 basically is meant to design the tunnel. It is to establish the tunnel. It doesn't have anything to do with sending traffic. That is why when the phase 1 is up, no traffic can be sent because its job is to set up a secure tunnel that will enable phase 2 to send traffic in between. And in phase 1, we have different modes. We have main mode and aggressive mode. We have main mode and aggressive mode. Main mode is majorly used, is majorly recommended, and then most of the time it is there by default because main mode will send 6 packets and they will be encrypted. Main mode will send 6 packets and they all be encrypted in phase 1. But if you select aggressive mode based on different reasons, but I've not seen aggressive mode used in production, but it can be used just for either to test or there's a need for it. Aggressive mode will send 3 packets and they will be all unencrypted. That's why it is not always recommended, because this tunnel, it is not fixed. It can be reconnected. It can be teared down and it can be reestablished. So if you select aggressive mode and then we want to reestablish it, for example, every time these 2 devices want to reestablish the tunnel, they will send 3 packets. The 3 packets will be unencrypted. When they are unencrypted and then there's a bad guy capture the session, they can capture the session, they analyze it, they will know much about our internal network. So most of the time, it is main mode that is recommended for phase 1. And on the phase 2 has only one mode, which is quick mode. all these packets cannot be seen with just a device. It is only be seen when we analyze the packet or when we see them on the Wireshark. So we have talked, so now we have phase 1, we have phase 2, and then when we go to the lab, I will demonstrate some of the concept more, and then we'll be able to dissect it more. But I just want to touch base on some of the basic concept behind the configuration, so that we don't want to just jump into configuration and start moving on. So we've touched based on the architecture of IPsec, and then IK phase 1 and IK phase 2. IK itself is Internet Key Exchange. Internet Key Exchange. What it does is this. We have the parameter. This parameter we mention now, those are the IPsec parameters that will form the security associations. So I've mentioned that phase 1 is designed to create a tunnel, while phase 2 is to provide secure traffic for the data. In other words, the phase 1 have a tunnel created. Inside the phase 2 we still have another tunnel inside the first tunnel. It will not be a tunnel as I said now, it will be encrypted. So it will be encrypted in between the tunnel. It's not that because we have tunnel created, I will now allow the traffic to flow unencrypted in between. No, the traffic will be encrypted again inside the tunnel. Because some people can still use their method to break the tunnel. We have seen a lot of documentation that shows tunnel being vulnerable, tunnel being captured. But if the data inside the tunnel is encrypted, even if the tunnel have issues for some reasons, the packet is encrypted. It will be scrambled. It will not be readable. So there are some method that other people, because as we speak, some people are very good to do evil in internet. They are very good. For example, now, if I've worked in an environment where we are the one that design all these parameters I'll be mentioning now, I can give somebody the code, the method that can, because every security tools, they have their backdoors. They have their backdoors. So somebody can give another person the secret. That is, if you do this, this can be done. So it can be hardened for us, but it is open to somebody else. So, but we are users when it comes to VPN. We are like users. We are not the one that provide the design or develop all the parameters. No, we are users. It's like we go to market, we buy the recipes, and then we want to make it to do so whatever we want. So what people think a lot of people do in IT is different from what we are really doing. We are like users, but users in IT level. All these parameters have been designed, has been laid and developed, already made. So the vendors acquire it, they incorporate it into their system. We are just there to configure it. If there's an issue or there are issues in between, and then we have done our best, we follow the standard, we follow the documentation, and then the device didn't work as well, what we need to do is to involve the vendors support team. So having said that, we have, when it comes to IPsec configuration, we have parameters that is recommended by standard to use. So the best way to understand them is to memorize this word, this argo. This parameters is set of parameters we'll be using to form the phase 1 and phase 2. They are available in phase 1 and phase 2. This argo, they are the baseline of the so-called VPN. Without all this, there's no VPN. So most of the VPN, they have this parameter utilized, either in IPsec or even in SSL. They have these parameters utilized. And then one another concept we made, lovely to paint small picture on in IPsec VPN is the mode in terms of transport and tunnel. We have transport mode, we have tunnel mode. This one, they use ESP, that is encapsulation protocol, and HA and AH, authentication header. Let me go back. Okay, this is HA, this is ESP. This is HA, this is ESP. Authentication header and encapsulation protocol. These two protocols, they have different functionality. I will just explain in a very simple way. When it comes to transport method, which is just in theory, we see that authentication header, what it does is this. This is a trailer. This is a trailer. This is our, let me just draw a trailer. This is a trailer, for example. Don't mind my drawing thing. This is a trailer, for example. And then if we are using authentication header, what is going to do, it's going to operate in a transport mode. Transport mode is in which sense? The header will be open it can be accessed if you filter the packet. And then they have different protocol number they use. That is in transport mode. In transport mode, when we use this kind of authentication or this kind of protocol, when we are selecting our parameters, this one, if, for example, we capture this packet, we will see the header, we can see the original IP, but the data will be encrypted. But in ESP, that's an encapsulation protocol, it will be in a tunnel mode. It will create a tunnel and put everything in between. So we cannot see both the header and the data we are transporting. So that is just major difference between these two protocols. And then we should know that IPsec tunnel, IPsec VPN is a layer 3 VPN configuration. So it works in layer 3 of OSI model. So quickly, let's take a look at some of the parameters I've been emphasizing on this morning. So number one, we have hash algorithm. Hash algorithm is part of the parameters that will ensure that the integrity wise, what we send, it's what we got. And then these two major parameters that is used in hash algorithm is MD5 and SHA, secure authentication. This one, these two methods, we can still use MD5 for some data that is not too sensitive. Maybe now I want to send you a file. I can use MD5. Most of the vendors, they use MD5 for their images to check if nobody has been tampered with it so that it can be compared. But according to this document, either shell 1 or shell 2 and all that, or the advanced one is recommended because MD5 has been proved to be vulnerable. The same other authentication-wise, this is the method both clients, the client and the server used to authenticate themselves before they started sharing data. Most of the time, we use PSK, that is pre-share key. Digital certificates can be used, but thousands of times you see that we use PSK because it's very simple to troubleshoot. Digital certificate can be very troublesome, but some organizations are still using it, but I've not seen it configured. Most of the VPN tunnel I've seen, they use PSK, that is pre-share key. Pre-share key is just a set of index or string agreed by both on the both sides. It must be the same on the both ends. If you use something on point A, on point B, it must be the same. So that is on authentication side. On the DFMA group, this is the management of the key. This is the management of the key. So this one, the VMN group, we have some other group too, but this is the one industry agree with. This one, it is this, the higher the number, the stronger it becomes. So if you select the VMN, this one is lower than this 2, but the caveat is this. This have computational issue on the device. If you select the highest number, it may have the CPU issue on the device. So if you are setting up a VPN for a company, we should consider the capacity of the device as well. Otherwise, the tunnel will be up, but the CPU level of the device may go up. So it is always recommended to use anyone that is the device is capable of. And another thing we need to know in IK version 2 quickly is that it has PSK, perfect secret key, perfect secret key. No, is it a perfect secret key? Perfect forward secrets or something like this. Yes. So this one, it is an additional layer of different element, but this one, IK version 2 support this PFS. So when we are setting it up, I will show us more about that. So I'm just explaining some of the parameters, what they do, and then how they behave. We can select any of this number when we're setting up our VPN. This is just a simple example. They go beyond these examples. The lifetime, and like I said before, lifetime of a tunnel, it is majorly, different vendors have different formats, but if it is 86,000, 8,600 is about a day or so. And if it is 36,000, it's going to be around 8 hours. So most of the time, some vendors, they put their lifetime by default to be 8 hours, while some vendor put their own to be 86. But it depends on the business need, and the lower the number, the better. So that if there's no traffic flowing in between the tunnel, it should be shut down until traffic started flowing again. So another parameter we need for IPsec configuration is what? It is encryption. This parameters is used to encrypt the packet. It's different from the authentication. It's different from the hash algorithm. Hash algorithm is to sort the packet, to sort the password. What hash does is to sort the password. It will make it unreadable. So maybe later I will ask this question before I say it. So Encryption is different from hash algorithm. They do similar work, but they are on a different level. Hash algorithm is to sort something and then make it unreadable. Encryption, the word encryption is to make it to unable to be deciphered by the third party. So we can use DES, we can use 3DES, we can use advanced encryption standard. All this one, the first two has been there's been known to be vulnerable. So it is not recommended to be used. So if you check this documentation, AES is the current standard, and then that is what most organizations utilizes. But you will not be surprised if you see 3DS in an environment because of we may have some legacy devices that doesn't support AES, or the capability cannot withstand AES. So that is just a brief overview of IPsec and the parameters and the VPN and some of the types of VPN we have in the industry. So before we jump to the lab, any question? Hello?
Yeah, I think most of the interview questions on VPN now, the trajectory has changed from just asking, okay, tell me overview of a VPN or IPsec, which and also you've already talked extensively on some of the questions that I think which I know they asking now, especially if you are interviewing with an Indian guy or or let me just say an Indian guy, like those messages that they send between the initiator and the responder, those packets are one of the major questions that they ask now when it comes to IPsec VPN. They want you to tell them about all the packets sent between the responder and the initiator. So let's just take note of that.
And then I mentioned that IK version 6, IKE version 1, and IK version 2, they have different message they sent. This one sent 6 message. This one, the latest one, sent 4 message. 4. So this is more quicker and faster than IK version 1. In IK version 2, we have 4 messages sent in phase 1. So the tunnel will quickly come up, and then it's more secure, it's more resilient compared to IK version 1. So we need to take note of that because they have asked this kind of question: what is different between IK version 1 and IK version 2? IK version 2 sent 4 packets in phase 1. In phase 2, they both use quick mode. So that is that. And then before this, can anybody tell us difference between hash and encryption? What is different between hash and encryption?
Well, what I know about that is encryption basically is encrypting the packet while in transit, right? Then for hashing, I might be wrong on this, but I think that's encrypting the packet while at rest.
You are still saying the encryption in the hash again.
So that's why I said I'm not really sure about the hash, but I know the hashing might be, encrypting it while at rest.
You don't use encryption. You can't use encryption in hashing. Hashing doesn't encrypt.
Okay. But the first one is encrypting it while in transit.
This one which one is while in transit? Which one?
The encryption.
Encryption can be encrypting either in transit, at rest, or in use anytime. It depends. Okay. So hash algorithm, but any question, anybody that can give us small overview of difference between encryption and hash algorithm, apart from what Mr. Dyer said now, any other person? I will say it and I will need to take note of it. Because they are not the same. Okay. So the major difference is this. Hash algorithm is majorly used to sort password. If you use this hash algorithm, the packet or the data cannot be reversed. It cannot be reversed. What does that mean? It cannot be unencrypted. If you sort anything, like I put in my password now, like password, for example, and I use MD5 or I use SHA-1 as hash algorithm, this password can be scrambled to be anything like H, D, D, F, E, and so on and so forth. This is hash of it. I can only compare the hash to hash. But if it's encrypted, if I encrypt my data, this example is password. For example, it can be decrypted to be password. It can be decrypted, but this cannot be reversed. This can be reversed. So in other words, this can be decrypted. Encryption can be, if the word encryption, it has the opposite word decryption. But hash, it doesn't have opposite word. So hash cannot be reversed. It can only be compared. That is what tests the integrity of the packets. So that is the major difference. All right, so not to waste time, let's go to our lab and then we test we do the demo for the site-to-site VPN. But before we jump into that, any question so far? It could be on anything related to VPN. And there's some of us who are hearing some of this word for the first time. Don't feel bad. It is always like that.
Hello, sir. I know we are dealing with a Fortigate, but sometimes I find it difficult to differentiate between the SSL VPN and a remote user VPN as Global Protect. I don't think we should talk about it, but sometimes it just confuses me.
It's the same thing. You are saying one word, different way.
SSL VPN and Global Protect?
Yes.
That's in the Palo world. It's called SSL VPN. You know, so don't get it confused. In Palo, they call it SSL VPN. It's the same thing as remote VPN.
I know, but so what you are saying in the Palo, Global Protect is the same thing as SSL VPN.
Yes,
That's
yes.
the clientless
Global
and the
Protect.
client-based. Okay.
Yes. Global Protect is the same thing as SSL VPN, yeah.
Okay, thank you.
Is that clear now?
Yes, it is. Thanks.
Okay. So in Fortigate, we don't have anything like Global Protect. What they have is SSL VPN clients. So now we are going to demonstrate this. I've configured this.
Sorry, Mr. Abe, but it can be clientless and a client-based, right?
That's another conversation. It can
Okay,
be clientless, it can be client-based.
Okay, sure, thank you.
But the clientless, most of the time, what they use the clientless for, in terms of Palo, is for maybe some of their visitors or some of their business partners that don't have the client app on their device. So they just configure a clientless VPN for them, whereby they can just access, specific application using the browser.
Okay, as a web page on a web browser.
Yes.
Okay,
Mm-hmm.
okay, sure. Thank you.
All right. So we are going to demonstrate how we can set up site-to-site VPN when it comes to Fortigate. Like I said before, setting up IPsec VPN, it involves two devices, Site A and Site B. So this is our headquarters, HQ, and then this is our branch office. So if we are trying to set up SSL VPN.
Mr. Abe, I think some people wanted to, they are in waiting room. Maybe just saying you should let them in.
Oh, I don't see anybody here. Oh, I don't see anybody here.
No, you already did. You already allowed them in.
Okay.
Okay. Okay. Thank you so much. So we are going to have some checklist of when we are trying to set up IPsec VPN. What are the checklists we need to have handy? Number one, we need to know our remote IP. That is, our pair IP must be known. That is pair IP. The pair means the remote server we're going to establish IPsec with. So we need to know the remote IP, which should be public IP of the external interface of the other side. We need to agree on the PSK, that's a pre-share key on both sides. This one must be equal on both sides. And then we need to know the remote subnets of where we are going to connect with. We need to have that in note, remote subnet. When you have all these parameters set, we can start establishing the tunnel. Another thing we need to have handy is the parameters we have mentioned before, the arrow, because we have different variants. So if I'm using MD5 and the other guy is using SHA-1, the tunnel will not come up. So we need to agree on all the parameters in this format. So in a business environment, there will be SSL and IPsec notes or IPsec tickets. Most of the environment, they have their standard. Our own is just to follow it. They will have what they agree in their environment in terms of all these IPsec parameters. So when the client or a requester open a ticket and it's coming to us, all these things will be there. What may not be there is just the password. Password may not be there, but every other things, the location-wise, everything will be there. And then what is approved by our manager, we can go on and set it up. So in this our demo, we are going to go to our machine now, which is this. So this one is 10.0.0.18. I'll click on it and then let's log in. This is Fortigate demo, but when it comes to other firewalls, they have their own standard too. They have their own formats. And then if you look at here, I have this image here. If you look at here, we have two FortiGates. That's why initially I encourage us to get this document handy. We can play around with it, we can read it. This FortiGate, they simulate exactly what we have in the lab. This is the headquarter one, this is headquarter two. Maybe the business have two headquarters. So they want to set up a secure connection between the sites. So these are the formulas, these are the steps they recommended to follow. And then if you look at here, this behind the firewall, this is 1, this is 2. If you look at the behind the firewall, we have 10.100.0/24. That will be the local subnet. If you look at the 2, which is 172.16.101.0/24, it will be our remote subnet. So this is just a diagram, the design to just, if you want to set up a basic tunnel. There are some other variations we can follow that will not be in this document. That's why if you don't have account with them, there are things will not work normal. So we can't just come here now, start designing a network for a company. No, it doesn't work that way. There will be additional input from business side. Otherwise, if everybody following this, the tunnel will not be strong. All right, so let's go back to our firewall. So the first step where we want to connect, we want to configure IPsec tunnel in Fortigate. Whether in Fortigate or any other firewall, the first recommendation is this. There must be a tested connectivity between the sites first. The two sides must be reachable. It must be reachable. Now, I cannot ping, if I cannot ping this IP from my side before the tunnel, how do I expect the tunnel to come up? The answer is no. So there will be already lay connectivity. They can connect without a tunnel. So what we're trying to do is to force the traffic after the tunnel to pass through the tunnel. I should be able to ping from my side my remote IP. That is, I should be able to ping my pair even before the tunnel from the device we are trying to set up with, not from the inside. If I try to ping this from this user now, I want to ping this, I may not be able. But between the devices, the communication must be established. They must be able to ping each other. So that is one prerequisite. Because if they cannot talk, cannot communicate, they cannot reach each other, they can't establish tunnel.
So that will be on the phase one.
There's not any phase. It's just what we need to have in mind.
But I think that's why we're authenticating those devices.
Don't get it twisted. I'm not talking about tunnel at all. What I'm talking right now is before we establish any tunnel, there must be reachability between the two sides.
Yeah, that's what I'm saying. I'm not talking about tunnel now. What I'm saying is for us to be able to ping those two, for those two devices to ping each other, they, in terms of communication, we have to establish, they have to authenticate each other on both sides. That's the only way they can ping each other. I'm not talking about the tunnel now. We've not done anything on the tunnel. We are still on phase one.
We have not even done any phase. What I'm saying is this: forget about phases. Okay, I want to set up a tunnel for for a client, two sites, site A and site B, for example. What I must make sure is before I even start my work, I must make sure that I can reach this site's IP first.
Okay.
You get the logic now?
That is, there must be reachability between the two sites first before you even think about tunneling.
Yep.
Okay, now what I'm saying is this. There must be reachability. How do we establish that reachability? To establish that reachability is basically on phase one, where we have to hold on.
Pinging.
Pinging.
What I'm saying is they have to authenticate each other first.
They need to forget about authentication.
What I'm saying is out first.
You see, the problem is this. If you authenticate, you set up a tunnel, for example, and then there's a device down in between. Maybe for my own environment now, if I stop this internet router and I did not try to ping my remote first, say, can I reach it first? If I set up the tunnel will not come up. So I'll start troubleshooting my configuration. I may spend days. Whereas there's a device in between that is done because I failed to test my connectivity before I started working. I don't know if we get the logic. So
which device are we pinging? Is it the one in the middle or the two devices in different branches?
Just a caveat. So now I'm setting up from point A and point B.
Okay.
This one is just an heads up for somebody who is working with VPN to try to ping the location we are trying to connect with first.
Okay.
Check it's just a checklist. Check the reachability before you start the configuration. Otherwise, if you cannot reach your pair, you configure the VPN failed to come up. You start troubleshooting A and B, and initially, both of them, they cannot ping, they cannot exchange connection before. This is why it always happen in a corporate environment. I set up this, maybe I'm a consultant for this business. I set up this network. I set up this network. So there's a requirement for me that, oh, we need a VPN. Before VPN can be even discussed, there's a cross connectivity between them already. That is what I want to establish.
Okay.
They can communicate, but over the internet.
Using the public IPs, right?
Yeah, using the public network.
Yes.
So now, the reverse case is this. Somebody just wake up in the morning, they establish a network, they don't test it, maybe they can communicate, just say, set up a VPN, they give you all the parameters. If you set it up, it will not work because there's not already established connectivity between the sites. So the two sides, they must be communicating already, but we want to secure the connection this time around. I hope it's clear.
Yeah.
So that's the point I'm trying to drive.
Okay. Yeah.
All right.
Yeah,
So
I understand what you're saying now. Okay, all right.
Okay. So now in Fortigate, if you want to create a site-to-site VPN, you just need to come to, there's a tab for it. If you can see my screen, there's a tab for a VPN. We need to click on that. And then before we establish our VPN, everything is already been designed. That's part of what I said just now. We have routes, because VPN is an overlay. It's an overlay technology. We have routes. If there's no route, for example, now if I go to my network, I click on static route. There's a route. There's a static route. If I delete this two traffic route now, the VPN will not have anywhere to lay upon. So our VPN is designed on top of already broadband connectivity, or is already connectivity that is designed or already configured. For example, if you look at our interface, this is interface we're going to use. We're going to use port 1. If this interface is done, for example, the VPN will be done. If you select this interface. In other words, this one will show us that VPN is an overlay on top of the already wired network. So all those wired network need to be in good shape. So all those things, we need to check them and then we make sure that they are in good shape. So let's go quickly because time is flying. We go to VPN. Fortigate, they have different flavors of VPN. We have overlay, control VPN, IPsec, tunnel. They have IPsec wizard, this and that. So we are going to use IPsec wizard. And then the other time we talk about SSL VPN settings. This is their own. So we touch base about this briefly, but I've tried before on their trial access, it didn't work. So I don't want us to waste time on that, but we need to understand the concept, but it's very simple to configure. So quickly, we want to use wizard. We can use wizard to create our tunnel. We can customize it on our own. This is a tab here. We can customize it. Customize means that we're going to create all the parameters ourselves, create the route for it, create the policy, and we'll create anything needed. But if you use the wizard will help us to create everything as we move forward. Our own is just to follow the supplied information and then we'll move forward. So let's quickly move. So the requirement is the name. So let's say we have headquarter VPN. So that is one of the requirements. And then they give us room to select type of the VPN we want to configure. So we have site-to-site, we have hub and spoke, we have remote access. These three can be configured in this device or on this device. So, but right now we are going with site-to-site. Another thing we need to pay attention to is this. If we are configuring remote device type on Fortigate, if it is Fortigate to Fortigate, we don't have issue. But anytime we are configuring from another between other devices, by default, Fortigate selects Cisco, but it could be Palo, it could be Juniper, it could be any other one. If we are dealing with any other vendor, we need to select this tab, which is different vendor. But every time we are selecting Fortigate, it is between two pairs of Fortigate. So quickly, let's move forward. So I've supplied my name, the name of the business, and then we are going with site-to-site. We see that there's no NAT between the two sites. If there's a NAT, we select this one. So we click next. So those are the things that was mentioned before. We have our checklist. On our checklist, our remote IP address, we'll go to our lab. We have, let's go to port 1. We're going to use this port on the remote side. That is 192.168.3.1. So we go here, we supply that information. 192.168.3.1. That is the IP of the remote server or remote device. So it's asking us for pre-share key for authentication. We can use pre-share key, we can use signature. We talked about this before where we're talking about pre-share key and certificate. So this is where it's asking us. If you have it, we need to upload it. Most of this certificate is provided by the certificate authority. So we are not going to use that. We're going to use pre-share key. I'm going to root admin 123. This password must be the same in both sides. If it fails to be the same, the tunnel we have issue. So we need to click next now.
Excuse me, sir.
Yep.
Yeah, please, before you click next, for that certificate, in case we're using that one, is that the certificate for the other side or for this side?
Okay. The certificate it's going to be installed in one of them. And then when we install in one of them, we now need to generate it and install it the other side too.
Okay, so what I understand is there was going to be a certificate for that VPN.
There will be not only for the VPN. You see, certificate is a form of authentication too. See, it's like this. We have certificates, CA, for our company. So there will be a server. There will be a server. I want just to use that one. But if it's a standalone, maybe you have like GoDaddy, you get your certificate authority. Anybody that signs a certificate, you need to download it to your system. If you look at here now, if when I click certificate, it's giving me option. So by default, Fortinet have their own certificate by default. If you have your own, it must have been in your system. You click here. Before we come here yourself, there will be there's a place where we can upload certificates. If I cancel here now, it will deprompt me. So we'll go and check that one later when it comes to authentication. So there's a place where we can upload our own certificate, but to be registered certificate, whether it be with it can be with Azure too, it can be with Azure, it can be with any other certificate providers, but it will be both on. It will be the same on both sides, and it's signed by the same authority. But it's very troublesome sometimes when the issue come up. I hope that was clear.
Yes, thank you, sir.
Okay. So we click next and then local interface. Local interface means where we are going to form the tunnel from. locally from the device. This is very simple. We click on 1.1. We're going to use 1.1 to connect, and then it said this is the local subnet. No, this will not go be the 1.1 here. Local interface will be our LAN. So I'll select 1. So this is the local subnet. On the other side, remote subnet. We need to know that one. Okay, this is 10.0.2.0. 10.0.2.0/24. So we are using the whole subnet. Internet access. Share local, use remote. None. Share one. All this one, they are new functionality. Remote, use remote. No. But once you supply all this, you click next. But Fortigate provide additional layers. That is, if you have more subnet to participate in this tunnel, you just need to add it more and more, and then click next. So now, if you look at here, it shows that it can create phase 1, and then it has created phase 2. Look at the name. And then it has created for us static route. And then it has created for us remote policy, local to remote policy, and then remote to local policy. These are the firewall rules. So if you look at here now, we need all these parameters to set up our tunnel. We need to know the interface. We need to know the local address. We need to know the remote address on the phase 1 and phase 2. And then the static route, we need to create a firewall policy to allow the rules, to allow the traffic to flow. So I'll just need to click create. So now as I create it, I'll go to this tab, IPsec tunnel on the left-hand side. I click on it. I'll see that the tunnel is done, is inactive. So what we need to do is to go to the other side. Most of the time, one person can configure the 2 sides. But let's assume you are in London, somebody's in the US, and then it is on site device. You just need to send your parameters to the other administrator. But it is more easier if one person does the same site, because he will be able to know what he or she put in place. All right, this is site 2, which is branch firewall. We go to the VPN. We go to IPsec wizard. We set branch VPN. All right, so we're going to do site-to-site VPN on these 2. And then we click next. Remote IP, which is our pair IP. It's going to be what? Let's go to the lab. We are using port 1, which is 192.168.1.1. 192.168.1.1. Okay, pre-share key, we use admin 123. Pre-share key is part of phase 1. We need to know that. Local interface will be LAN, and then our remote subnet will be 10.0.1.0/24. Okay, and I will click next, and I will click create. See, it's very, very easy to create the tunnel on both sides. That does it on the FortiGate. So we go to tunnel, and then we see that it is what? It is inactive. So if you double click on it, it will take me to this place. So we can right click on it and then do off face selector. We can, once there's a drop down here that goes to the right, it is the one that gave me this. You can say select phase 1 or select all phase 2 selectors. So if we do that, it may propagate the tunnel to come up. So if you look at the tunnel now, it's not up yet. Unlike in Palu that you need to send a traffic, but in Fortigate, you just need to come here, select phase 2, and then you refresh it. You can refresh it. So, but on the 2 side now, our tunnel is still down. So let's try to ping from inside our tunnel. So I will try from this VPC. So we try to ping the remote site, which is 10.0 dot what? .2 dot, let me see the IP of this one. Show IP. Okay, 10.2.2. 10.2.2. Okay, it's saying it's not reachable. So the tunnel is not up. We need to start troubleshooting it. View the template, edit. So what may be the problem? So let me run this command to see what is going on in the tunnel. Now, one command here. All right, let me see this one. Fortigate has debug command to troubleshoot. All right, this is the responder. Yes, connecting state started 23 ago. 1 to 1 to 1 to 500. IKESA created, IPSA created, IPSA 0. Okay. Let me use the second command. Diagonals IPSec VPN stay out. I hope I have on this thing back. The server. Okay, connection 1/2. IKSA. All right, so let's go to the lab. Let me check this device in between. But if it is problem, oh, look at it. This is what we failed to do the right time now. We did not check. Okay, let's do that one quickly. You can see that the device in between is not connected. It's not configured. So let me quickly configure that. Let me quickly configure the router. It was configured before, but maybe because I powered it down and then everything wiped out. I don't know, but we can quickly set it up. Let me see if I have the configuration here. So if that one is not configured or we have issue in between, the system will be behaving the way it is now. All right, let me see. I'll just run the script.
Can you please show your OneNote for the command, sir?
Say that again?
Your OneNote for the commands. Or your notepad, sorry. Yeah, thank you.
Okay. Okay. Okay, give me 1 second. Okay, let me see. This interface is 0/. Okay, I want to use 0/0, 0/0, which is 1.1. And then the other one is /1. And then is yes. And then, okay, let me do look back that .1 and then 3.1. Okay, let me run this command quickly. This command is run on the device in between. So now, if we did not check this one and started troubleshooting the tunnel, it will become a waste of time. So now we have the device in between configured. Show IP interface brief. All right, this one is up. So let's check our tunnel again. All right, so now we can see the tunnel is established now. So let me see the other, list it. So it lists our tunnel for us. So you can see that we are having our address with 500. This 500 is designed for IPsec IKE. So this is the protocol for the tunnel, IKE 500. But if there is a NAT transversal or there's a NAT device in between, this protocol will be changed to 4500. But if it's nothing is in between, it will be 500. It will be listed on 500. So we have this, we have our tunnel IP, and then the tunnel is established. And then we have our protocols. Okay, if I copy all this now, this is our phase 2. So now we can see that this our device here is the initiator. See it here. The direction is initiator. This guy is the, if I refresh it here, I'll see the tunnel is up. So phase 1 is up. Bring the 2 up. Phase 1 is up and then phase 2 is up. So what did I do? I just right click and I select, because it's up now, it's not giving me option. I just select bring the state up. So let's go to our device this time around to test again. This user, and I'm trying to ping, I try to ping this network. If you see, before we try to ping this device from our headquarters, which is this guy, trying to access this device before it was not working, but after the tunnels come up, we could pass through the tunnel and then we see the traffic is flowing. So tells me that let's try to capture this traffic. We capture it, we go to 00. I'll click OK. So while that one is going on, we'll be doing some complete continuous pinging from our side there. Though now we may not be able to see much, but we see that before we establish a tunnel, if we capture it, we see all the messages, everything setting up from point A to point B. So now the tunnel is up. This is our initiator. This is our responder. let's assume that this server, it is where we store our resources, and all the users in the branch, they need to access this. So with this tunnel established now, this guy, they will be able to access the device in our headquarters securely without exposing our data to the internet. So this guy, they will pass through the tunnel and then they will come to the server here. If I try to reach this server from any of the device from the branch, they should, just by pressing the IP address. So that is it. If you look at it, it is not complex to create in Fortigate. It's not really complex. So I just need to refresh it, or I just go here. So any question or any confusion, any doubt? So that's just it. I don't want it to take much of our time. So let me see if I can on the network. So in Fortigate, if you set up a VPN finish and they want to check, you don't want to go to the tab, you can come to the network here. You see the net. If you have any VPN, you will see it here. Fortinet, they did a good job here. They show all the routes established, connected. If you have a VPN, if you even have any other thing, there's a wizard. You can have additional wizard here. You can have an additional wizard here. Maybe we have HA. If you have HA, or if you want to show the administrators, just hide it. So it's showing that only one admin is connected for now, and then I have access to the HTTP and console. So that's just it. That's a simple demo for the configuration of site-to-site VPN. And then we've tested it, we can access the device. And then if you try from this device to this guy, our Windows server is .20. So if you're trying to ping it, you can ping on both sides. Ping 10.0.1.20. This device is listening on .20. So we can see that we can access it from the branch. So let's go and check our capturing. So now we see that IPsec is coming up. A ESP is showing. So let's filter by ESP. Encapsulating payload security, internet protocol. So it's showing they're using IPsec protocol version 4, IP version 4, reference service, the flag. That's not what I'm looking for. The encapsulation payload. The source, the destination. Let me cancel this one. Let me see if we capture that. Doesn't give us, doesn't give me an option for that. We can only see the ESP. We are seeing the ESP payload. We see the source, we see the destination. But now, let us mean that it is a flow of data in between the site now. If there's exchange of data between the site, we should not see it. This guy, they will encrypt it. They will encrypt it. So, and then let me even see what this guy used for us in phase one. We go back to our tunnel. We go to edit. So if you want to edit it, you just click on edit. Go to advanced. Version 4. You put all the parameters there. Authentication. Okay, we'll use pre-share key. Okay, while I'm checking this, any question? I want to check the CD. Not this one. Hello? Any question?
Is there any limitation to that wizard in the in the Fortinet? Is there any limitation of what it can do, or that's very good. It makes it very simple.
What is the limitation?
No, I mean, is there anything that wizard can do? I mean, I'm just asking. I can
The
see
only thing he
it
cannot do, the only thing he cannot make Gary, he cannot make Koliteba. Koliteba. He can't
okay, because that's very good.
So he cannot make a bar for anybody now. But maybe in the future. So it's very, very, even it's not only in Fortigate, even in Cisco SA, they have a wizard. Only Palo doesn't have wizard. Yeah, so it makes life easy.
Very easy, yeah.
Yeah, it makes life easy. If I want to customize it, I can download the scripts, even from their own documentation. Look at the script here. Look at the script here. You can copy this script, modify it to suit your own environment, and paste it. It will do the justice. So let me stop so any questions so far? Any